Welcome to myprojectbazaar.com. Our product title is Sensitivity Analysis on Locations of Energy Storage in Power Systems with Wind Index. Let us see about the abstract of our product. The penetration of renewable energy sources, particularly wind energy, into power system has been rapidly increasing in recent years. However, the integration of wind power has posed many challenges for power system operation. For instance, this type of energy source is relatively variable and unpredictable. The installation of this renewable source might require the grid to transmit power at full capacity, and some transmission lines would become congested. As a result, in some operating conditions, wind power could be curtailed, which will drive up cost for system operators. One of the actions that can be taken to support the integration of wind is using energy storage systems. In this proposed system, a multi-period AC optimal power flow problem with battery energy storage is formulated, and set of candidate buses for battery energy system installations are identified based on an economic criterion. Tests are carried out on IEEE 14 bus and IEEE 118 bus system to access the robustness of storage location and the system operation. In this proposed implementation, we did only the client requirement, and also we using general available IEEE 14 bus system and 118 bus system data. And also in this paper they not given the clearly constraints and also the some parameters variables values. So we consider as a general values, and also that constraints are considered as a general things. This is the flow of given 6 bus system value and 14 bus system diagrams, and also what is the generator, which one is the system compensation, all are given, which one is the wind plant, all are given in this diagram. The methodology of to define the most suitable candidate locations for energy storage system is described. The optimization is carried out on the total generation cost, which represent TSO's point of view. In other words, the goal is to improve system operation regardless the revenues of the single companies operating wind farms. Energy storage system therefore can be installed at any bus by the TSO in order to maximize the efficiency and security of the overall system. Moreover, the total time horizon considered, which could be either 1 week or 1 month or a set of representative week of the year, is discretized, and the hourly operations is optimized considering the presence of the energy storage system. A multi-period approach is necessary to properly model the intertemporal constraint characteristics of the energy storage system. A multi-period AC optimal power flow model with energy storage system integration can be formulated as follows. The objective function to be minimized in the module in the total production cost using an control variable energy storage system, charging and discharging power and generation output of all dispatchable generation in each period. In order to take into account the variability of load and wind, two possible approaches are available. The first is to run the module on a longer time frame, 1 year. However, the traceability of the resulting problem is subjected to the size of the system. The second approach, which is typically used in power system planning, is to run the module on a weekly basis, considering a number of weekly scenarios representative of the most significant loading and wind conditions: high wind, high load, high wind, low load conditions, weighting the result based on the weekly energies. Therefore, the value of T depends on the time horizon adopted in the planning problem. Next, we see about the running process of our product. In this proposed implementation is done in MATLAB environment. In this implementation is done in the MATLAB M file coding. So solve the objective functions and using of the given constraints, equality and inequality constraint taken us to consider. So first of all, we get the bus system available IEEE bus system only we consider. So we using in this implementation two kind of bus system. One is 14 bus system, another one 118 bus system. So in this process only we did for the client requirement. So this only we did and corresponding output waveform only here we presented. So in this 14 and 118 system having data of sending in and receiving in branches values and bus data values and generation cost values, those are the given in the IEEE available bus system data. So that data is considered as to solve the formulation of objective function. So after formulated that objective function using of constraints, the waveform will be plotted using of the general commands. So first one is the amount of current wind of all cases. So this waveform is plotted between wind in megawatt hour and case. And next one is the production cost of all cases. So this is drawn between cases and cost in dollar. So the five kind of waveforms will be drawn in the production cost. And next one is the operational schedule of BES in case 2, and also this is drawn between the power in at a time megawatt and is drawn between the time. Next one is the hourly LMP variation in case 2, and also it's drawn between the hour. So those waveforms are drawn using of total hours. So next one is the hourly LMP variation in case 1. So these are the waveform. Next one, in the figure 1 we draw the case 0 hourly LMP variation and is drawn between 24 hours. So this implementation is similar to 118 bus system, and additionally some values only cases will be added. So these are the output of the corresponding process. Thank you for watching this video.